All right, so in this video, what I want to do is make sure that you understand the key points of section 2.1. So I felt like people have a pretty good handle on percentile and things like that, and the cumulative relative frequency graphs, or the percentile graph. So I'm going to be focusing on the adding, subtracting, multiplying, and dividing. All right, so I'm going to flip to the last page of this lesson from 2.1. This is not a page that we got to during the lesson, but I think it kind of hits this concept pretty well. So you have this information about temperatures. The temperatures are in Celsius and they want to convert them to Fahrenheit. And you have measures of center, which are mean and median. You have measures of variability, range, standard deviation, and IQR. And you have measures of what I'm going to call location: max, quartile 1, min. It's just a location. It's not a measure of center or variability. So we have a multiplication, which is a rescale, and we have an addition, which is a shift. So essentially what's happening here is I'm taking the data, multiplying it by 9/5 and adding 32 to every piece of data. And I'm trying to think about what's going to happen to each of these measures. Well, the max, the same exact thing is going to happen to it. The new max is going to be 9/5 times the old max plus 32, whatever that is. Because it's just a measure of location, it's affected by any shift or rescale. The mean is a measure of center. We know that center is affected by rescales and shifts. So I'm going to do both. So if you think about center variability, if this chart's helpful, we have shift, which is addition and subtraction, and rescale, which is multiplication and division. Adding and subtracting does affect center, but not variability. Multiplying and dividing affects both. Shape is not affected by any of those. Range is a measure of variability, so it does get affected by the rescale, but not the shift. So I would not add 32 here. Standard deviation, same thing. It's a measure of variability, so it's not affected by the shift. And IQR, same thing, not affected by the shift. So basically, if you think of a box plot, and I just shift this over one way or the other, the IQR, the variability stays exactly the same. The range might be 10, 50, so the range is 40, and then maybe I add 100, it's 110 to 150. The range is still 40. It didn't change. Same idea with the IQR. Standard deviation is a little harder to see. What I'd suggest doing is reading through question 2, pausing the video, and trying to work through this on your own. So we have fines for speed limits, and they want to find the mean, the max, the standard deviation, and the IQR. So max is a measure of location, mean's a measure of center, standard deviation and IQR are measures of variability. So it's automatically $100 plus $10 per mile over the limit of 20 miles per hour. So the max they told us was 33. So it's going to be $100 plus 10 times 13. They're going 13 miles an hour over the limit of 20. This fine is going to be $230. It's a measure of location, so it's affected by both the shift and the rescale. Mean, same deal. Measures of center are affected by the shift and the rescale. The mean was 28, so they're on average 8 miles over the speed limit. This would be 180. Standard deviation is a measure of variability, so I don't do the shift. That's not changing the variability among the speeds. So I'm just doing the rescale. And the standard deviation for the cost would be $24. And then for the IQR, same thing. The shift does not apply to measures of variability. The IQR was 3.2. The rescale does, so the IQR for the fines is $32. So hopefully this video helps kind of clear up some of those questions as far as when to perform the operations depending on the set of data to the mean, standard deviation, etc.